Assalamualaikum and good afternoon, respected lecturer and fellow classmates. Today, I would like to present our project titled Innovative Mini Crane Prototype using 3D Model and 3D Printing. This is a part JJ 40383 Engineering Design Course. Our group members are his name. My name is Adam Michael bin Abdul Rahim 01 DKM 24F 1001. I will go first to introduction. This project focus on the design and fabrication of a mini crane prototype using modern engineering tools in integrate CAD modeling, 3D printing technology and mechanical assembly. The project is based on the approved case study developed earlier. The final outcome is a functional prototype with control the mechanical movement. Next slide is project objective. The first objective is to apply 3D modeling skill in design a complete mini crane with a pure dimension and proper structure. The second objective is to execute the correct digital workflow from CAD design to 3D printer preparation. Third objective is to operate the 3D printing machine safely and efficiently during the fabrication process. The final objective is to assemble the prototype and demonstrate a smooth controller and stable mechanic movement. Next slide is CAD design development. The mini crane design was developed using CAD software with proper engineering consideration. Each component was carefully designed with accurate dimension to ensure proper fitting during assembly. The main part include the base crane support structure and mechanical joint. The design was adjusted and improved to achieve better stability and functionality. Final, finally, CAD model represent the complete structure before fabrication.
Assalamualaikum and good afternoon to all beloved lecturer. My name is Putra Amin Ismail bin Muhammad Fauzi, matrix number 01 DKM 24F1009. And I am a student of engineering design from class DKM 4A. Assalamualaikum and good afternoon. Today, I would like to give my appreciation and thanks to my friends for presenting before me. And now I will do my part. This, as been shown on the slide, is the parts of the crane, of the mini crane. The hook, the base, the arm, the crane base, and the connecting joint. All of these design were made inside Autodesk Inventor. And now I will talk about the workflow of the 3D printing process. First, the CAD design was converted into an STL5 format. So, what is an STL file? STL stands for the Standard Tessellization Language. What is the Standard Tessellization Language? Is the format for 3D printing and CAD software. It represents the surface of geometry of a 3D object using small and tiny triangles that we cannot see. So then, STL files were imported into slicing software for print preparation. The best representation of an STL file would be Automaker CUDA, if I'm not mistaken. Slicing, a 3D printing tool. What is slicing? Slicing is actually a 3D printing tool that translates digital 3D model into an instruction so that a 3D printer can understand and can see the design. so it can be printed. The workflow, excuse me, it's important to set up parameters such as the layering, the height, the infill density, and even the support so the printer can make a good printing as in shown in the image. And the final file was transferred to the 3D printer for fabrication. Excuse me. Lastly, for a more detailed process of the whole 3D printing, we'll go for step 1, create the design in the create the CAD design in the Autodesk Inventor or any Autodesk apps or software to design the 3D model. Step 2, export the file as a STL file and save the design. Step 3, slice the model and open the STL file in slicing software like the Ultimaker Cura. Step 4, prepare the 3D printer and load the filament. Best example filament that's been used by a lot of 3D printers is PLA. Step 5 is preheat the printer. How do we preheat the printer? It's the simplest method. It's just turning on the printer and leave it on for a few minutes. Step 6, start printing by transferring the file to the printer and begin printing. Step 7 is post-processing. Is the post-processing. What is post-processing? Post-processing is to remove the supports and clean the model if necessary. This includes sanding and etc. That will be all for me. Thank you.
Assalamualaikum and good evening. My name is Mohamed Azim and my matrix number is 01DKM24F1012. First, we're using 3D printing to manufacture every single component of this project. Uh, Second, we choose PLA plastic because it is easier to work with, and provide great strength for our parts. Before starting, we calibrate the printer to ensure every part was printed with high accuracy and fit together perfectly. Finally, we allow stretch safety produce pro- produce throughout the entire process to ensure everything has handled correctly. Okay, to fabrication and assembly process of our crane project. Once the printing has complete, we focus on preparation. Our parts were thoroughly cleaned and prepared to ensure they were ready for assembly. During the assembly phase, we follow the original design strictly. Each component was put together step by step to maintain the integrity of the build. The crane, the crane incorporates a specific mechanical system focus, focusing on a joint or spring magazine mechanism. This system is the core of the crane movement. To finish, we ensure proper alignment of our parts. This is a critical step to make sure the crane overall stability and its ability to function correctly. For mechanical movement, uh, we were we done uh, for mechanical movement. Our task is the movement can be rotated up to 3 300 316 degrees of vertical movement with range, but we only need one only, so we choose one movement component as as selected for the aggregation for the average. The mechanism was tested to ensure smooth operation. The movement must be controlled, stable, and consistent.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iman Zakwan bin Nur Zaidi. My metric card number is 01DKM24F1013. Okay, on this slide, I will present the demonstration of our mini crane prototype. During this assessment, we tested the selected mechanical movement to ensure it functioned properly. The movement was demonstrated clearly to show its performance. Throughout the operation, the structure of the crane remained stable and intact. This show and confirm that our design and assembly are strong and reliable. Overall, we found that the system functioned according to design requirement, and the prototype was able to perform according to the required specification. Okay, moving on next on this slide, we will talk about our first challenge during this project. Okay, first of all, we were having issues with printing machine. It's mentioned here that layer misalignment that can cause weak spot or even uneven spot that can cause the project not follow the specification given. There are also possible support material issue that can make removing it hard on small and detailed part. And it is also possible that the printing machine were failing during printing due to the long operation time. Moving on next to the assembly issue, where part of the crane could have tight tolerance and making hard to fit. Sometimes sanding is needed to get it smooth movement. Screw or joint also might fail because it's printed plastic, whereas this is not strong enough to handle pressure. There's also issue with material where we face. One of it is strength limit of material like PLA will not handle heavy load. The part for the combine could deform due to shrinking, which could affect the part's accuracy. There's also function challenge where crane effectiveness can decrease due to the friction while moving. The base also could tip when lifting object not suitable for the size of the crane. Also, and lastly, it is also have a very limited load capacity due to a lightweight material. Since we use plastic for our material, so in the end, I can say that we have achieved successful in this project and follow the objective given. We also, as a student, gain experience in CAD design and also 3D printing workflow. A functional and stable mini crane prototype was produced and successfully functioned. And thank you for your attention during this slide. I would like to we would like to thank you guys for watching and listening.